Hello, today I'm going to talk about the Chapter 1, Section 2 study guide for pressure and fluid systems. I'm going to start by giving you the vocabulary word definitions. I have them typed up to make it easier to read than my writing, and I'm just going to start. A solid is a state of matter characterized by particles arranged such that their shape and volume are relatively stable. A liquid is one of the states of matter. The particles in a liquid are free to flow, so while a liquid has a definite volume, it does not have a definite shape. A gas is defined as a state of matter consisting of particles that have neither a defined volume nor a defined shape. Plasma is a state of matter where the gas phase is energized until atomic electrons are no longer associated with any particular atomic nucleus. A fluid is any substance that flows or deforms under applied shear stress. That means of the four states of matter that we have, liquids, gases, and plasmas are all fluids. A hydraulic system is a fluid system that uses a liquid as the working fluid. A pneumatic system is a fluid system that uses a gas as a working fluid. A material's density is defined as its mass per unit volume. A material's weight density is defined as its weight per unit volume. Pressure is defined as the measure of the force applied over a unit area. A Pascal is an SI unit of pressure that refers to newtons per square meter. Buoyant force is the upward directed force that a fluid exerts on an object that is partially or completely immersed in the fluid. Archimedes' principle states that any body completely or partially submerged in a fluid at rest is acted upon by an upward or buoyant force, the magnitude of which is equal to the weight of the fluid displaced by the body. Pascal's principle states, in a fluid at rest in a closed container, a pressure change in one part is transmitted without loss to every portion of the fluid and to the walls of the container. A barometer is a device that measures atmospheric pressure. Absolute pressure is the total pressure at a point in a fluid equaling the sum of the gauge pressure and the atmospheric pressure. Atmospheric pressure I added for you because, honestly, it was a mistake that I didn't have it in there in the first place. Atmospheric pressure is the pressure exerted in every direction at any given point by the weight of the atmosphere. And lastly, gauge pressure is the pressure at a point in a fluid above that of the atmosphere. Okay, now we're moving on to the short answer. I'm sure the vocabulary words were as exciting to hear as they were to read. All matter is made up of what two types of particles? The answers are atoms, which make up elements, and molecules, which make up compounds. What two states that we deal of matter are considered fluids? And as I mentioned in the vocabulary, there were three of them, but again, we only deal with two, so those are liquids and gases. What is a working fluid? It is the fluid that moves and does work on other parts of a fluid system. Give two examples each of pneumatic and hydraulic systems. So I will start with pneumatic, and the first example I am going to give is the body's respiratory system. The second example that I'm going to give is an air compressor. For hydraulic systems, the first example that I will give is the body's cardiovascular system. And my second example is going to be household plumbing. What is the prime mover in a fluid system? Remember, prime movers are what make things move, not what is moving. So in a fluid system, you have a fluid, either a gas or a liquid, that is moving, but what causes those to move is pressure difference in the system. What symbol is used to represent density? Okay. It is the Greek lowercase letter rho. What is the unit that is equal to a Newton per square meter called? Well, that was one of our vocabulary words up above. It is called a Pascal. Remember, Pascal is abbreviated capital P, lowercase a. What must exist in a fluid system in order for liquid or gas to move? Well, we already said that, and it is a pressure difference. Number 9, using Archimedes' principle, explain what happens to a ship if the density of the water displaced is less than the density of the ship. The ship will sink. Because the buoyant force will be less than the weight. Of the ship. Number 10 says, Pascal's principle provides the basis of operation for what very useful devices? And those are hydraulic systems. And now we're on to the problems. Remember, when you're solving these problems, they should look similar to the problems that I solve. You should have your equations, possibly your variables and what they mean, and you of course have to have units on all of your answers. Number 11 says, a sample of aluminum is placed in a 25 milliliter graduated cylinder containing 10 milliliters of water. The level of water rises to 18 milliliters. The mass of the sample is 22 grams. What is the density of the sample? So we need to find density. We have the mass is equal to 22 grams. We don't exactly have the volume. However, we have the volume with the water and the aluminum, and we have the volume of just the water. So we could figure out the volume of the aluminum by subtracting those two values. So for the water and the aluminum, the volume is 18 milliliters. For just the water, it's 10 milliliters. So the total volume of the aluminum becomes 8 milliliters. So to find the pressure, to find the density, Density is equal to mass divided by volume. The mass is 22 grams. We're dividing it by a volume of 8 milliliters. And when we calculate that answer, 22 divided by 8 gives us 2.75 grams per milliliter. Number 12 says, you place a 28.95 gram piece of gold in a 10 milliliter graduated cylinder. The level of water rises 1.5 milliliters. What is the density of gold? Again, looking for density, we're given that the mass is equal to 28.95 grams. We are given the volume in this case because it tells us how much the water rises, not the total volume of the water and the gold together. So the volume is 1.5 milliliters. Density is equal to mass divided by volume. The mass again is 28.95 grams. We're dividing it by 1.5 milliliters. And 28.95 divided by 1.5 gives us 19.3 grams per milliliter. Number 13. A sample of silver has a density of 10.5 grams per cubic centimeter. So density is 10.5 grams per cubic centimeter. If the volume of the sample is 3.5 cubic centimeters, what is the mass of the silver? So we're looking for mass, M, and we know the volume is 3.5 cubic centimeters. Taking the equation density is equal to mass divided by volume, and solving it for mass, we do so by multiplying both sides by the volume. On the right side, the volumes cancel out, and we're left with mass is equal to density times volume. The density that we have is 10.5 grams per cubic centimeter times our volume of 3.5 cubic centimeters. When we multiply these, we get 36.75 grams, because the cubic centimeters in the denominator of the density cancels out with the cubic centimeters for the volume. So we get 36.75 grams of mass. Number 14, find the pressure produced by a force of 250,000 newtons exerted over an area of 500 square meters. So straightforward pressure problem. Pressure is equal to force divided by area. So our variables are P, F, and A. Pressure is what we're looking for. The force that we're given is 250,000 newtons. We're dividing it by 500 square meters. Pressure is equal to force divided by area. 250,000 newtons divided by 500 square meters will give you 500. Newton divided by a square meter is called a Pascal. So our answer is 500 pascals. Number 15. Consider a block of material that is 12 centimeters by 7 centimeters by 2 centimeters and has a mass of 175 grams. What is the volume of this block? So to find volume of a block, which is a rectangular prism, we use the formula volume is equal to length times width times height. So here we have a block 12 centimeters by 7 centimeters by 2 centimeters. So its length times width times height is 12 centimeters multiplied by 7 centimeters multiplied by 2 centimeters. Putting these into my calculator gives me 168 cubic centimeters. What is the density of the block? Okay, so we need to take density, mass, and volume. We found the volume above, 168 cubic centimeters. We were told the mass in the original problem, 175 grams. Density, of course, is equal to mass divided by volume. So 175 grams divided by 168 cubic centimeters gives you 1.042 grams per cubic centimeter, which does not have any particular unit name, so we just leave it as grams per cubic centimeter. Will this block float or sink in water? To know that, we need to compare it to the density of water. So the density of the block is 1.042 grams per cubic centimeter. In grams per cubic centimeter, the density of water is 1. Because the block has a density greater than the density of water, the block is going to sink. Part D says, if the smallest side of the block is resting on a surface, what is the pressure it exerts? So the smallest side of the block is the 2 centimeter by 7 centimeter side. To find pressure, remember we take force divided by area. So the force that this block is exerting is equal to the mass of the block times 9.8. Except that mass has to be in kilograms. And we also need to find the area of the smallest side, which is equal to its length times its width. So in this case, that's going to be 2 centimeters by 7 centimeters. But if we are changing our mass to kilograms, we should also change our dimensions on the length and the width to meters. So this becomes 0.02 meters by 0.07 meters. Because remember, you divide 2 centimeters by 100 to get meters, and you divide 7 centimeters by 100 to get meters. So when we calculate this area, we have 0.02 times 0.07. We're going to get 0.0014 square meters. To find the force, we need to take the mass that is in grams, 175 grams. To change it to kilograms, we divide it by 1,000. When we do this, we get 0.175 grams. So to find the mass, we take 0.175 grams times 9.8, giving us 1.715 newtons of force. Finally, to find the pressure, we take the force in newtons divided by the area in square meters, 1.715 newtons divided by 0.0014 square meters. And we get 1,225 newtons per square meter, which is called a Pascal. Part E is very similar, but it wants the biggest side of the block resting on the surface. So the biggest side of the block is the 12 centimeter by 7 centimeter side. So just like we divided 2 and 7 by 100 to get the length in meters, we need to divide 12 by 100 to get the length in meters. And when we do that, we will get 0.12. So our area for this one is going to be 0.12 meters by 0.07 meters, giving us 0.0084 square meters. The force is the same because the block is the same weight, 1.715 newtons. And again, we're looking for pressure, which is force divided by area. So we take the 1.715 newtons divided by 0.0084 square meters, and we get 204.17. Again, newtons divided by square meters, pascals. And now problem number 16. Consider a block of material that is 12 meters by 7 meters by 2 meters and has a mass of 450 kilograms. What is the volume of this block? So right away we can see that this is a very similar problem as the previous one, except our units are different. Here we're given kilograms and meters as opposed to grams and centimeters up above. So for volume, we're going to do length times width times height again. And this is going to be the same 12 times 7 times 2. See? Look. Same numbers, different units. So 12 times 7 times 2 is, of course, still 168. But now we have meters times meters times meters, which is cubic meters. So 168 cubic meters for our volume. What is the density of this block? Density is equal to mass divided by volume. The mass is 450 kilograms. The volume is 168 cubic meters. 450 kilograms divided by 168 cubic meters gives you 2.68 kilograms per cubic meter. Will this block float or sink in water? Well, in order to do that, we need to know that the density of water in kilograms per cubic meter is equal to 1,000. Once we know that the density of water in kilograms per cubic meter is 1,000, we can compare it to the density of the block, which is 2.68 kilograms per cubic meter. We can see that the density of water is much greater than the density of the block, so it is going to float. Part D says if the smallest side of the block is resting on a surface, what is the pressure it exerts? So the smallest side of this block is going to be that 2 by 7 meter side. So pressure is equal to force divided by area. Area, of course, is equal to length times width. In this case, that is 7 meters times 2 meters, so 14 square meters. The force is the weight of the block. So the mass times 9.8. The mass is already in kilograms, so 450 kilograms times 9.8 gives us a total force of 4,509.8 newtons. Pressure, of course, is force divided by area. So we have 4,509.8 newtons divided by 14 square meters, giving us 322.13 Newton per square meter is a Pascal. Part E says if the biggest side of the block is resting on a surface, what is the pressure it exerts? So same problem. Force divided by area. The force we figured out above, 4,509.8 newtons. This is the area of the big side, so it is going to be the 7 meter by 12 meter side, which is going to be 84 square meters. The force is 4,509.8 newtons divided by 84 square meters, which is 53.69 pascals. Lastly, number 17. Imagine a spherical helium balloon with a radius of 2 meters and a mass of 0.6 of a kilogram. What is the volume of the balloon if the density of helium is 0.164 kilograms per cubic meter? Determine both the mass and the weight of the helium in the balloon. First of all, to find the volume of the balloon, it has nothing to do with the density of the helium. The volume of the balloon is simply finding the volume of the sphere, because it says it's spherical, which is 4/3 times pi times the radius of the balloon to the third power. This becomes 4/3 times pi times the radius of the balloon is 2 meters. So 2 to the third power. Calculating that, we get 33.51 cubic meters. Technically, since I told you not to round off until the very end of the problem, we should say that this volume is 32 pi over 3 cubic meters. Determine both the mass and the weight of the helium in the balloon. So to find the mass of the helium in this balloon, we're going to use density is equal to mass divided by volume. The density of the helium we are given 0.164 kilograms per cubic meter. The volume we just calculated as 32 pi over 3 cubic meters. We're looking for the mass. We know from up above that mass is equal to density times volume, because we've already solved this equation for mass. So the density is 0.164 kilograms per cubic meter, multiplying by our volume of 32 pi over 3 cubic meters. The cubic meters cancel out, so we know our answer is going to be in kilograms. If we multiply 0.164 times our volume, we will get 5.5 kilograms for our mass. To determine the weight, that's going to be our mass times 9.8. That's going to be 5.5 kilograms times 9.8, which is going to be 53.86 newtons. And that's the end. If you have any questions, please feel free to ask.